Hi everyone, we're finally at the final video of this section, which is about difference quotients. And this is a very important definition if you are moving to calculus, because basically in chapter 2, you will be, in calculus, you will be calculating a lot of difficult difference quotients. And the difficulty is not really calculus, it's really algebra. Can you do the algebraic manipulation? So my goal here today is to make sure that you understand how to do difference quotients, understand some of the geometry behind the difference quotient, so that you are better prepared to tackle this topic in calculus. So the definition of the difference quotient is here, and it's defined as being f of x plus h minus f of x all over h, where f of x is some given function. And so let's take a look at the geometry first of this, before we even look at the algebra. Geometry, sorry I keep hitting the erase button. So let's look at some particular function here. I'm just going to draw something very generic. And we're going to look at some point x, and we're going to look at, we'll call this x1, and we're going to look at some other point down the road called x2. Now, these 2 points have a distance between each other, and this distance here is going to be known as h. And so, instead of writing x as x1, we are going to write it as just simply x like that. And then this is just going to be x plus the distant h. So really all we're doing is changing a little bit of notation here. And then notice that here, this corresponds to the point x comma f of x. And then this point right here corresponds to the point x plus h comma, let's write that a little better. So x plus h comma f evaluated at x plus h. And so what we want to do is we're going to take these 2 points on the graph and we're going to join them with a line. So let me pick a different color here for the line. So let's do our usual red here. And we want to know what the slope of that line is. And this line actually has a name as well. This line is known as the secant line. And the word secant comes from Latin, which means to cut. I believe the verb is secare. I believe that's how you spell it. I'm not exactly sure. It may actually be a E there. I'm not sure. I'm not a Latin expert, so anyone who knows Latin, feel free to correct me. And this means to cut. And the reason we call this tangent line is because it's cutting through the graph. And so the idea is, what is the slope of this line? So let's figure it out. So here's my 2 points, and so the slope, let's move back to the other color, the slope is going to be the change of y over the change of x. Well, what's the change in the y coordinate? Well, it's just going to be the f of x plus h minus the f of x for the y coordinates. In the denominator, we are going to get the x plus h from over here, and we're going to subtract off the x from over here. And when we simplify the denominator, guess what we get? We get the difference quotient f of x plus h minus f of x all over h. So basically, given 2 distinct points on the graph of a function, the difference quotient then is just the slope of the line connecting those 2 distinct points on the graph. And that works when points are distinct, but what happens in this situation? When the distance between the 2 points is equal to 0, or other words, what happens when the points are not distinct? The points are not distinct. So let's draw a picture to show what I mean. Is that we have some generic function here, and we have some point here, x, and our h is 0, so our second point is also x as well. So we're looking for a line that just touches at that single point. And this is called a tangent line. But there is a problem. If h is equal to 0, then look at the difference quotient. The difference quotient has 0 in the denominator. And how do we get around dividing by 0? Well, we have to see calculus for that. So that's the part that calculus plays. The role is how do we deal with dividing by 0. So this difference quotient plays a very important role because basically everything in calculus, at least in Calc 1, at least in the background, is all about difference quotients. You may not always be calculating them in later chapters, but really everything is related to difference quotients in some way. So if you're moving on to calculus, you should know how to do these algebraic calculations. So let's do some calculations. Well, let's go this way instead. It won't let me go up or down until I guess I write more. So example. There we go. Let's change over back to a different color. So let's look at the function f of x equals x squared plus x plus 1. And let's find its difference quotient. So the difference quotient again is given by f of x plus h minus f of x over h. So notice that this x plus h in the parentheses right here, we're going to have to treat this term in the numerator like we did with our last example from the previous video where we took x and replaced it by x minus some number. So it's going to be the same type of procedure. So let's give ourselves a lot of room. Sorry, there's a little bit of dust on the screen. So again, to figure out f of x plus h, so I'm actually going to give myself a little bit more room here. And it's misbehaving. There we go. So in the numerator, we have to figure out what f of x plus h is. So when we have x squared, we're going to put a parenthesis there and square it. When there's an x, we're going to put a parenthesis there and raise it to the first power. Then we're going to bring along the plus 1. And so what goes in the parentheses? Well, whatever in this parentheses goes in these ones. So this will be x plus h and x plus h. So this is the first common mistake, is that a lot of people makes this substitution wrong, and that's why I made a big deal about using parentheses in the previous video, because that helps in minimizing the errors here. Now the second error that people make is that we're going to have a minus sign, and then we're just going to write f of x. But we need to distribute this negative sign to every term in f of x, so we need to put a parenthesis so we remember to do the distribution. So we're going to have a x squared minus an x, plus x in the parentheses plus 1 and close the parentheses, and this is all going to be divided by h. Now the unfortunate thing that's going to happen here is that we're going to have to multiply and simplify that numerator out. So let's do that. So this first term is going to become x squared plus 2xh plus h squared. Then this plus x plus h just comes along, so that doesn't change. The same thing with the plus 1. And then all we need to do is distribute this negative to all the terms, so we'll get a minus x squared, a minus x, and a minus 1. And that's going to be all divided by h. And notice something really interesting happens here. Let me change colors. This x squared cancels with that x squared. This x cancels with that x, and this one cancels with this one. And notice something peculiar in the numerator. We get a 2xh plus h squared plus h, and we're going to divide that all by h. And notice that in the numerator, every term has an h in it. And notice in the previous step, every term that had just an x or a number in it got canceled off. When you use the difference quotient with polynomials, this always happens. So this is a way to check yourself. If you have a polynomial and you get to this step and the numerator has a term with only an x or only a number in it, then you have made a mistake and you need to go back and check your work. Because the trick here is that we want to factor out, sorry, they're just random bug here. Factor out an h here, and we factor out an h. So we're going to get a 2x plus h plus 1 all over h. And while I said calculus dealt with the h in the denominator, actually algebra takes care of it. And we cancel off that h. And that's 2x plus h plus 1. And then the calculus will tell us how to get rid of this h here. And that has a very special, and once we get rid of this h, we'll have a very special equation that is a very important class of equations in calculus. So, but again, we'll leave that to calculus. For right now, our answer is just going to be 2x plus h plus 1, and we'll leave it to calculus to fill in the rest of the blanks. So these are just the basic types of different quotients that I would expect you to do. When you get to calculus, you'll do more complicated ones, but right now we just want to get the basics down so we understand the substitutions, so that when we get on to the harder stuff in the future course, we're able to handle the hard stuff and not trip ourselves over basic stuff like this. So thank you for listening to all these videos, and good luck on the practice problems, and I will see you on class on Wednesday.